Okay, now we're going to discuss about properties of parallelogram and rhombus. I know it's geometry, but it has to do with vectors because we're going to use some properties of the vectors to prove whether a particular quadrilateral is a parallelogram or a rhombus. So before we use the vectors to prove that, we must go through some properties of a parallelogram and a rhombus. So let's very quickly go through them. If you have a quadrilateral like that, ABCD, how do you show that it is a parallelogram? It's only a parallelogram if, for example, if AB, this vector AB, must be parallel to this vector DC, and furthermore, not just parallel, but they must be also equal in length. Correct? Must be equal in length. So in vector form, if I can express, if I say A, B here, AB, vector AB is the same as vector DC. Actually, in itself, in this thing, there are two things. There are two ideas. One is first, they are parallel. Second, they're equal in length. So vectors has this beautiful thing that I can talk about the direction and the magnitude. Right? In a similar way, if I can say AD and BC, just these two pairs, these opposite pairs, all right, this is a parallelogram if AD is parallel to BC and equal in length to BC, then yes, then it's a parallelogram. I don't need to prove these two and these two. Just one pair will do. So it's an or here. I just want to emphasize it's either this or this. It's either A or B. So a quick recap. Either you prove AB, vector AB equals to vector DC here, or vector AD equals to vector BC here. The next 2 points I will just quickly go through because usually we will use point A and point B, these two ideas, to prove parallelogram. But you could also use C and D here to prove a quadrilateral is parallelogram. You can say, oh, okay, all right, AB parallel to DC and AD parallel to BC. So I'm just talking about direction, nothing to do with magnitude. If you just prove direction, then you need to prove two sides and two sides. Lastly, the diagonals bisect each other, which is talked about here. We really seldom use it, but we bear this in mind, this property of a parallelogram in mind. All right, just want to add a quick note. Usually, 9 times out of 10, we will use point A and point B to prove parallelogram. It's neatest. It really is the neatest. Next, let's talk about this shape called a rhombus. A rhombus is a special parallelogram. Let's bear in mind. I repeat one more time. A rhombus is a special parallelogram where all the four sides are equal in length. I repeat, a rhombus is a special parallelogram where all the four sides are equal in length. To prove a rhombus, okay, first you could do this to say, okay, the vector AB equals to the vector DC. Correct? Vector means the direction are equal and the magnitude are the same. But that's not enough. That is what we use to prove a parallelogram. In addition to that, you can also show that the length AD is equal to the length AB. So I'm going to write it out here. Okay, if you can somehow show AB is equal to DC, that means this talks about direction and magnitude. Correct? But not enough because this first point will only show that ABCD is a parallelogram. ABCD is a parallelogram, but not enough. To show that it's a rhombus means all four sides must be equal. So you must add an additional idea that AD and AB are the same. Same length, not parallel, of course, cannot be parallel. AB and AD are the same. If AB and AD are the same, then all the four sides are the same length. Then it must be a rhombus. Of course, you could, all right, you could also prove the other pair like that by saying, okay, AD vector and BC are the same, which means you show that it's a parallelogram again. Furthermore, you say the same pair ABAD are the same length. It's actually the same idea. Of course, the most clear-cut one that is easiest to prove is a rhombus is you say, oh, okay, all four sides are the same length. Of course, all four sides. You don't think it's just a square, all right? Of course, a square I have all four sides equal, but a rhombus have also four sides equal as well. If you prove all four sides are equal, you're actually proving it is a rhombus, not necessarily a square. And finally, this one is, you must take note, a rhombus is a special shape where the diagonals not just bisect each other, but bisect each other at a right angle. Previously, if you go back to the previous slide, a parallelogram, the diagonals bisect each other, but they don't bisect each other at right angle. Only a rhombus diagonals bisect each other at right angles. Don't believe you draw 1 million and one quadrilateral. You realize that only the rhombus diagonals bisect each other at right angles. All right, that's that.